So, for example, you have a function f of x equals x squared. Just a simple function, f of x is equals to x squared. I'm going to translate this function. Let's suppose 3 units up and 2 units to the right. 2 units to the right and 3 units up. So this is how I'm going to translate it. Now there are three things going to happen. First of all, what will happen graphically? The same curve will move 2 units right and 3 units up. Right now the vertex is at 0, 0. Later on, vertex is going to be on 2 and 3. That's one thing, like graphical transformation. Second thing is what happens to the notation itself. So this is the notation of the function f of x. For this one, I'm going to do x minus 2 and then plus 3. So this is the second chain. The notation changes. Third thing, the function itself also changes. X minus 2 whole square and then plus 3. So these are the three things which we'll be looking into throughout the transformations. Okay. So no matter what type of transformation we're doing, we will always be looking into these three different things. Okay. One, the change in the graph. Two, change in the function. Three, change in the function notation. Okay. So any changes expected to be asked by the examiner. Now let's proceed further today. We are done with the reflection, we are done with the translation. And in our last lesson, we combined the reflection and the translation together. Today, we are going to look into stretch. When we started off this topic, I told you that the transformation which you studied in your GCSEs, that was in that transformation, there was no stretch. Earlier, long time ago, it was like it used to be a part of the syllabus, but not anymore. So you haven't studied this. Now, what is stretch? Now, stretch is changing the size of an object in. Now, there are two definitions. First of all, like the one basic definition is, like, for example, if you have a square, if I stretch it just horizontally, it will become a rectangle. Okay. But if I stretch it horizontally and vertically exactly by keeping the same aspect ratio, then the new larger shape is still going to be a square because, for example, initially, if it was, for example, initially I have something like this. This is, let's suppose, 2 units and 2 units. If I increase the size of this one, forget about this part. Okay, now this is 4 units and 4 units. Now it is increased by a factor of 2 horizontally and vertically. So this is basically known as enlargement. This is not stretch. Stretch is one definition is you only stretch like in one particular direction. Or if you want to stretch in both the direction, horizontally and vertically, then the aspect ratio won't be same. Let's suppose you're doing it 3 times horizontally and 2 times vertically, and that is known as stretch. Okay, the same stretch is known as enlargement if the aspect ratio or the scale factor is exactly the same. ठीक हो गया? अच्छा जी, अब stretch वाले concept को देखें, हमने इसको graphically किस तरीके से लेके चलना है. I'm going to draw a Cartesian plane here. Let's suppose this is the Cartesian plane. As a circle. Let's suppose this is 2, 2, minus 2, and then minus 2. Okay. So I have drawn a circle just to give you an idea. Just to give you an idea कि stretch क्या है, ये function नहीं है. If you recall दिस इज फेलिंग द वर्टिकल लाइन टेस्ट। सिर्फ एक स्ट्रेच का आइडिया देने के लिए मैं एक सर्कल से लेके स्टार्ट कर रहा हूँ, ठीक हो गया? बिकॉज वो फंक्शन हो या किसी भी शेप पे अप्लाई करें, प्रोसीजर स्टेज एग्जैक्टली द सेम। Now this is a shape, a circle. I want to, let's suppose examiner asks you to stretch it. Let's apply a vertical stretch, a scale factor 2. Scale factor 2. Now, while doing stretch, there is a very important line which is known as invariant line. Which line? Invariant line or the baseline, because that is your reference line. ठीक है, वहां से आपने देखना है कि हर पॉइंट का डिस्टेंस कितना है। ठीक है ना। वर्टिकल स्ट्रेच, आपने वर्टिकल स्ट्रेच करने का मतलब है यू आर गोइंग टू डायलेट द शेप of the graph vertically. Now, while dilating the shape vertically, there is a center of it. And in this case, that center is known as the x-axis. Okay, while stretching the graph vertically. Now, this line acts as an invariant line. So in a vertical stretch, invariant line is the x-axis, invariant line or the baseline. Okay. Now, all the points on the invariant line, the transformation will not be applied on it. Like for example, this particular part of the circle, we will not be stretching it because it is on the invariant line. Same goes here. Okay. All the other points, they will be stretched vertically. Now, how do we apply the stretch? I'm not going to apply it on every point, so I'm going to apply on the main points here. So let's say this is the point. Now, this is how you are going to apply the stretch all the time. I'm applying the stretch factor of 2. So I'm going to see what is the distance of this point from the x-axis. As you can see, in this case, it is 2 units. So apply the stretch factor of 2. So 2 times 2 will be 4. The new point is going to be on 4. All right. Same goes here. Acha, this point does not go anywhere as I stated earlier because it is on the x-axis. This is also on the x-axis. These points will be stretched definitely. Okay. Now let's come to this point. Same 2 units after stretch factor will be at -4. अब ये शेप ड्रॉ करेंगे। ये हमने इस सर्कल को vertically stretch कर लिया। Now I'm going to stretch the very same circle horizontally. For that, I'm going to do the horizontal stretch. Let's suppose the scale stretch factor is 3. While applying a horizontal stretch, the invariant line is the y-axis. Because in a horizontal stretch, you're moving along the x-axis. So the center line is the y-axis. So y-axis acts as the invariant line. Now let's apply the stretch factor here. So now this point and this point, these two are free from stretch. We won't be applying stretch on. We won't be stretching these 2 points because this point and this point here, they are on the invariant line. Okay, we will be stretching it like this. So this point here is 2 units from the invariant line. After applying this stretch factor of 3, 3 times 2 is 6. इस जगह पे, ठीक है? This point here of the circle is 2 units away from the invariant line. After applying the stretch factor, it will be -6 here. Now I'm going to draw the shape. As I stated, this point is not going anywhere, okay? It's not a circle anymore. We have obtained two elliptical shapes. ठीक हो गया? अगर मैं इसको 3 units horizontal, 3 scale stretch factor horizontally और stretch factor 3 vertically करता, तो फिर आपके पास वो सर्कल ही रहता, सेम. ठीक हो गया? Alright. So this is how you basically apply the stretch. यहाँ तक कोई प्रॉब्लम कि ग्राफ के ऊपर क्या इफेक्ट आएगा? यहाँ तक कोई प्रॉब्लम? अच्छा, अब मैं यहाँ पे एक क्यूबिक इक्वेशन का ग्राफ बनाता हूँ, उसको हम स्ट्रेच करेंगे. चल, इसको स्ट्रेच करना है वर्टिकली विद स्ट्रेच फैक्टर ऑफ 3. करें शाबाश. I want you to apply a vertical stretch on it with a stretch factor of 3. Vertical stretch invariant line कौन सी होगी उसमें? X axis. शाबाश. अच्छा जी, इसको यहाँ से देखें, because we are going to stretch this vertically. Now this is the invariant line. All the points on the invariant line, they stay as it is. We are not going to be worrying about them. Or every other point we are going to stretch it, especially those which are mentioned by the examiner. So let's just start from extreme left here. This is the extreme left. Uh, That's the first point we are coming across, which is mentioned by the examiner. Now, its distance from vertical distance from the x-axis is 2 units y coordinate. Okay, so if we apply a stretch factor of 3, this is going to go up to 6. So here, this point will be moved up to -1 and 6. This is on 1. If we apply a stretch factor of 3, this will move up to 3. Then this point is on the invariant line, so we are not worried about it. This is not on the invariant line. Its vertical distance from the invariant line is -1. So 3 times -1 is going to be -3. So this is where it is going to be, and the new coordinates will be 2 and -3. This point is on the invariant line as well, so we should do. Just if you focus here, this point shall move down, and this point shall move up. We don't know exactly what point it is, so we are not worried about it. So let's just start from the obvious points. There you go. I'm going to complete the graph like this. Like this. Okay. So this is how you're going to apply stretch. This was a vertical stretch. Now let's do one more graph where we should, I would like you to do the horizontal stretch. एक ही ग्राफ के ऊपर किया करें बच्चे, ठीक है? सेपरेट सेपरेट नहीं, उससे आइडिया नहीं होगा. जो एग्जामिनर ग्राफ बना के देता है उसके ऊपर ही किया करें. This is the graph of a quadratic. Let's apply a horizontal stretch on this one. On the same graph, on the same grid, draw the graph of this, which is stretched horizontally. Stretch factor is 2. इसी ग्राफ के ऊपर बनाइएगा. हॉरिजॉन्टल स्ट्रेच करना है. इनवेरिएंट लाइन आपके पास y एक्सिस होगी. हर पॉइंट का y एक्सिस से डिस्टेंस डबल हो जाएगा. इतना डिस्टेंस ऑलरेडी है, उसका 2 टाइम्स डिस्टेंस हो जाएगा, क्योंकि स्ट्रेच फैक्टर 2 है. वर्टिकली पॉइंट्स को नहीं छेड़ना, वो जहां पे हैं वो वहीं रहेंगे. अच्छा ये सॉरी मैंने उल्टा लिख दिया, ये 1 - 2 लिखना था। x पे 1, y पे -2, सॉरी। जी जी, हॉरिजॉन्टल स्ट्रेच में y एक्सिस, ठीक है, इनवेरिएंट लाइन बनता है। इसको याद रखने के लिए देख लिया करें, अगर आप इस चीज को हॉरिजॉन्टली स्ट्रेच कर रहे हैं, द डायरेक्शन ऑफ योर थंब इज बेसिकली द लाइन, वो इस y एक्सिस अलॉन्ग होगा, ठीक है। जब आप वर्टिकली स्ट्रेच कर रहे हैं तो ये x एक्सिस बन। अच्छा जी, इसके अंदर अब हम क्योंकि हॉरिजॉन्टली स्ट्रेच कर रहे हैं तो हर पॉइंट को हमने हॉरिजॉन्टली, जो इनवेरिएंट लाइन के ऊपर एग्जैक्टली पॉइंट्स आ रहे हैं वो एक ही आ रहा है, इसको हमने नहीं छेड़ना, ये यहीं पे रहेगा। अच्छा, ये मींस ग्राफ ने डेफिनेटली यहाँ से गुजरना ही गुजरना है, एक पॉइंट तो ये हो गया। ये -2 पे ये किस पे आ जाएगा बेटा? -4 पे, तो ये 4 पे ये किस पे चला जाएगा? ये 8 पे चला जाएगा, डबल हो गया डिस्टेंस। ये जो वर्टेक्स है ये 1 यूनिट अवे है फ्रॉम द इनवेरिएंट लाइन, तो ये किधर आ जाएगा? 2 यूनिट्स अवे। तो ग्राफ आपका यू कुछ जाएगा, maybe use a different pen here. It almost look flat from the lower end because we have stretched it horizontally. This was just to give you an idea that what happens to the graph when you and how you're going to do invariant line का concept, क्योंकि IGCSE में आप इसकी practice नहीं है। Now let's see what how to go about its notation. जो इसका notation है वो किस तरीके से है। ये मैंने लिखवाया था notation इसका, चलिए नहीं लिखवाया तो लिखवा देते हैं। Vertical stretch. If you have a function f of x, तो इसकी नोटेशन में अगर आपने स्ट्रेच फैक्टर k के साथ उसको वर्टिकली स्ट्रेच करना है, तो ये सिंपल हो जाएगा k टाइम्स f of x। ठीक हो गया? उसमें स्ट्रेच फैक्टर क्या होगा? k। For horizontal stretch, if you have f of x और आपने स्ट्रेच फैक्टर k ही रखना है, अगर स्ट्रेच फैक्टर k ही रखना है हॉरिजॉन्टल स्ट्रेच में x के साथ, जब भी हम कोई चेंजेस लेके आते हैं, this happened in the translation as well. It was the opposite behavior. So same will be here in this case. So f of 1 over k into x. ठीक है? इसका ऑपोजिट स्ट्रेच फैक्टर k का मतलब 1 over k. तो अगर इधर 1 over 2 लिखा हुआ है, अगर इधर 1 over 2 लिखा है तो स्ट्रेच फैक्टर क्या होगा? और इधर 1 over 4 लिखा हुआ है तो स्ट्रेच फैक्टर क्या होगा? अगर इधर 4/3 लिखा हुआ है तो स्ट्रेच फैक्टर क्या होगा? 3/4। ठीक हो गया? ऑपोजिट रेसिप्रोकल में डाल रहा है। अगर इधर 2 लिखा हुआ है स्ट्रेच फैक्टर क्या होगा? 1/2। ओके, ये दिस ओनली हैपेंस इन द हॉरिजॉन्टल स्ट्रेच। अच्छा, अब मैं आपको इसका क्वेश्चन देते हैं एक, ये लिखे। f of x maps onto g of x with vertical stretch by stretch factor 4. Find g of x. हाँ, सबसे पहले नोटेशन फॉर्म लिखते हैं. So g of x is actually, what is it? g of x कैसे बन रहा है कि f of x को क्या कर रहे हैं? Vertically stretch कर रहे हैं by stretch factor of 4. So f of x vertical stretch है, stretch factor 4, तो वो बाहर multiply हो गया. So this is what is going to happen. 4 times the f of x. That is going to give us g of x. अब g of x लिखें क्या आएगा? g of x will be 4 times 3x minus 5. That was notation up here. यहाँ पे मैं proper function लिखने लगा. So g of x equals 12x minus 20. Okay. इसी तरीके से अगर एग्जामिनर कहता है f of x maps onto g of x, तो चले g of x हो चुका है, h of x कर लेते हैं. h of x with horizontal stretch by stretch factor 4. Find h of x. सबसे पहले जैसे यहाँ पे हमने नोटेशन लिखी थी g of x की, पहले नोटेशन लिखेंगे. So how we are going to obtain h of x? By stretching the function f horizontally by a scale factor of 4. Now horizontal stretch means we are going to make changes in x. So this is going to be f of, yes, shabash, 1 by 4 x. Now let's write f of 1 by 4x then. h of x. So f of 1 by 4x means in the function f, x की जगह क्या किससे रिप्लेस करेंगे? 1 by 4x और x by 4. So 3 into x by 4 in place of x, and then minus 5 as it is. And this leaves you with 3 by 4x minus 5. So this is horizontal stretch by a stretch factor of 4.
Sir, अगर दो side से like stretch apply करेंगे, what if it's horizontal and vertical stretch at the same time?
Yeah. Yeah,
What
we
are
can do
we
that.
gonna do then?
We can do that. If it's vertical, the process, the phenomena stays exactly the same. For example, you want to do both at the same time. Okay. So this was, we applied, let's suppose this is g, this is h. Let's suppose we have a function q of x. And the q of x is a vertical stretch by a scale factor 4 and a horizontal stretch as well by a scale factor of 4. So q of x is going to be vertical stretch as well as the horizontal stretch. Got it? So that's the notation. Now 4 times f of 1 by 4x. So this is f of 1 by 4x. इसको 4 से multiply कर देंगे. ठीक है? So that will be horizontal stretch as well as the vertical stretch. Clear?
Yes.
उस पे बता. ठीक है? उस पे हमारा अभी एक क्वेश्चन आया है कि अगर ऐसा हो तो पहले हॉरिजॉन्टल करेंगे या वर्टिकल करेंगे, इसके ऊपर हमने बात करनी. ठीक है? अच्छा, चलिए ये क्वेश्चन था, ये मैंने किया। इसी तरीके से आई एम गोइंग टू गिव यू फंक्शन नाउ, और मैं आपको इसी तरीके से 2 क्वेश्चंस दूंगा आपने करने होंगे। ओके, let's suppose we have a function x squared minus 3x plus 5. Actually, sorry. 3x squared minus 7x plus 2. 3x squared minus 7x plus 2. First part is f of x is mapped onto g of x with vertical stretch by scale factor of 2. Find g of x. And then f of x maps h of x horizontal stretch by stretch factor 1/3. Find h of x. Do it exactly in the same manner. Like first, write down its notation part. This is the notation part, and then the function part. It's the notation part, and then the notation. Do it exactly in the same manner. पहले g of x की notation लिखेंगे, इसी तरीके से h of x, फिर उसके बाद function लिखना है. Okay, good. Okay, अच्छा जी, तो g of x is equals to 2 times f of x because it's a vertical stretch, so we'll multiply with the y. ठीक हो गया, तो y के साथ multiply. तो ये आपके पास आ जाएगा 2 times 3x squared minus 7x plus 2, 6x squared minus 14x plus 4. This is your g of x. Let's do this one. H of x is actually f of 3x. ठीक हो गया? Let's find f of 3x now. 3 into 3x whole squared minus 7 into 3x and then plus 2. All we have done is replace the x of the function f with 3x. And that is going to give us 9 square, 3 square is 9, 9 times 3 is 27, x squared minus 21x plus 2. This is your h of x. I hope you all got it right. Great. F of x equals x squared minus 3x plus 5 f of x is mapped onto g of x. ये लिखते हैं साथ में. Find g of x in each case. The cases are, first one, reflection in the line y-axis. Second, reflection in x-axis. Third, stretch in y direction. Stretch factor 3. Fourth, stretch in x direction. Stretch factor 1/2. जी ऑफ एक्स निकालते जाए आप सारों के साथ. Finally, translation -2, 4. थोड़ा सा recap भी हो जाएगा. Done? याद रखें वर्टिकल जब भी ट्रांसफॉर्मेशन कर रहे हैं ना, वर्टिकल फौरन से इस तरीके से हवा में ही मार्क लगाएं दिमाग में, तो ये किस में चेंज आता है? y में. So you need to make changes in y वाली साइड. हॉरिजॉन्टल ट्रांसफॉर्मेशन जब भी कर रहे हैं तो जैसे x के अंदर चेंज लेके आना. ठीक है, हो गया. ओके, सो g ऑफ x आपके पास बेसिकली इसमें बनेगा माइनस f ऑफ x, which is going to be minus x squared minus 3x plus 5, which is equals to minus x squared plus 3x and minus 5. ये आ रहा है ऐसे ही. Reflection in x-axis. So g of x will be f of minus x. हॉरिजॉन्टल अब x एक्सिस के अंदर, ओह उल्टा कर दिया मैंने, उल्टा कर दिया. ये नीचे हो जाएगा था. दिस इज रिफ्लेक्शन इन y एक्सिस, तो ये हॉरिजॉन्टली रिफ्लेक्ट हो रहा है, तो ये होगा f ऑफ माइनस x मीन्स minus x squared minus 3 into minus x plus 5, which will be x squared plus 3x plus 5. Reflection in x-axis. X-axis will be the line of reflection. तो ये vertical है, अब इसमें वो होगा जो पहले लिखा था. Minus f of x, which will be minus x squared plus 3x and minus 5. Stretch in y direction. So g of x is equals to 3 times f of x, 3x squared minus 9x plus 15. Stretch in x direction. So g of x stretch factor है 1 over 2. So f of 2x, very good. So 2x whole squared minus 3 into 2x plus 5, 4x squared minus 6x plus 5. Translation minus 2, 4. So g of x, f of हॉरिजॉन्टल ट्रांसलेशन है -2 यूनिट्स टू द लेफ्ट, तो ये क्या होगा x प्लस 2. वर्टिकल ट्रांसलेशन है 4 यूनिट्स अप, बाहर आ जाएगा +4. तो f ऑफ x प्लस 2 आपके पास बनता है x प्लस 2 होल स्क्वायर -3 इंटू x प्लस 2 प्लस 5. दिस इज f ऑफ x प्लस 2, फिर बाहर +4 भी है. So x plus 2 whole square is a squared plus 2ab plus b squared. Minus 3 into x is minus 3x, minus 3 into plus 2 is minus 6, plus 5, plus 4. X squared plus 4x. 1 minus 6 is minus 5 plus 5 cancel हो गया, plus 4 बच जाता है आपके पास. सही है, तो ये हो गया आपके पास क्लियर. अच्छा ये x था, कैलकुलेशन में गड़बड़ आ गई. -3x, यस. तो 4x, तो ये हो जाएगा प्लस x, फिर आपके पास आ जाता है 4 प्लस 5 9, 9 प्लस 4 13. 4 प्लस 5 9, 9 प्लस 4. अच्छा ये -6 भी है, कितना आता है x squared plus x plus 7. गुड, ठीक है। ऑनलाइन स्टूडेंट्स क्लियर हुए? चलें जी, लास्ट पार्ट करें आज का। टाइम तो हो गया लेकिन जल्दी जल्दी बस ये भी कर लेते हैं। g of x is equals to 5 times f of x। बताएं जी ये क्या हुआ है, फिर डिस्क्राइब करते जाए। वर्टिकल स्ट्रेच, स्ट्रेच फैक्टर क्या होगा? 5। शाबाश। अगर g of x है आपके पास f of x plus 3 then minus 2, ये क्या हुआ है? शाबाश। दिस इज ट्रांसलेशन। ट्रांसलेशन वेक्टर क्या होगा? वेरी गुड, -3 -2। g of x minus f of x, ये क्या है? कौन सी वाली? रिफ्लेक्शन इन x एक्सिस। शाबाश, वर्टिकल रिफ्लेक्शन। ठीक हो गया। फाइनली g of x is equals to f of 4x। ये बताइए क्या होगा? शाबाश, दिस इज हॉरिजॉन्टल स्ट्रेच। स्ट्रेच फैक्टर क्या है? 1/4। Excellent. That's it. From tomorrow we will do combined transformation। ठीक हो गया? चलो, ओके जी, टेक केयर, अल्लाह हाफिज।
Officer.
अल्लाह हाफिज।